I'll slow down my, are we ready yet? I'll slow down my speech because we're doing a wide, long video instead of a short. Something that people don't understand with shorts a lot of times. You just got to do things quick, get on with it, get it done, and you miss things. People are always asking me about names and terms, and they're saying, oh, did you forget? It's not so much that I forgot it, I didn't know which one I wanted to use. Most of the things I work with have 6 or 7 different names, depending on what vintage it's from. You read these antique engineering journals and stuff, and it's not just the name, it's the right name that the majority of people are going to recognize. That's what I'm trying to come up with most of the time. Anyway, totally irrelevant to what we're talking about. We're talking about, and I call this floating parts, is what I'm currently calling it. I may have different names for it over the years. But what we had at first, and let's just grab a piece of material here. First time that I ran into this, somewhere around this size of a piece of stock, although a little bit longer. And most likely, it didn't seem obnoxious in our shop, and the shop was a lot smaller than shops that I worked in afterwards. They might still be in business. It was actually, I heard they moved to Portland. It was A1 Precision in Vancouver, Washington, that I worked at the time. I'm guessing it was a 12-foot bar. We ran a lot of 12-foot bar stock there. We had some 20-foot stock though too, I think, but mostly 12-foot for the lathes and things for rounds. I'm not sure. But I remember it was on a Friley horizontal mill, which was a number 0, I think. It was a 0 or maybe a 1. This is a 2. I don't have any of them that small. It was a little machine. And what we had to do was cut a key down the whole length of the shaft. And this was my first experience with that. And they say, oh, we do this all the time, no big deal. And we put the cutter in here. Fact is, the machine was so, and last I knew, I think A1 Precision is probably all CNC now. They had just ordered their first CNC when I quit working there and moved to Alaska. I'd imagine they're all CNC. They were doing short-run production when I was there. Mostly we were running turret lathes was the big money at that time that I was there. Anyway, mill, a circular saw cutter on an arbor in a mill, cutting a slot along in a piece of shaft. And the job was to make the whole piece of shaft with a key from one end to the other end, which was a first for me too, as far as fully keyed shaft. I kind of think it was 1.25 inch shaft. I don't remember for sure. I remember that it was for one of the bottling companies for soda pop. And I'm thinking it was 1.25 inch, which is the bigger size for the overhead doors. And they do use shafting for that. Since the guys were doing it themselves rather than probably going through a door company, they may not have understood that the stuff was dirt cheap if you just bought it from a door company, because they buy it from wherever in thousands of feet. Anyway, pretty regular job. I did it in a matter of the 6 months or so that I worked there. I probably did 2 or 3 of them, so it was fairly common for us to be doing these shafts. And the trick was, which was new to me, was we'd bolt it down on the table over there, and then we would go ahead, and on this end we'd have a little roller stand on the far end. And as it goes on and towards the middle, it could just set in the table and you'd roll it along. And to make sure it was straight as you went, you actually just used the cutter to guide where it was, which works a lot of the time. It depends on how much accuracy you need and the length of your keyway all the way down. There's other ways to do it, but it was a very good first seeing this done. And we started kidding about our precision ground floor, because while this was, and I was just amazed that it would work, because I'm like, and the reason it was working was because even at 1.25 inch stock, and I think it was just 10/18, your stock can bend. You clamp it down, it's stronger than the table, it's stronger than, or the little rubber wheels or whatever on our cart would squish down. It was strong enough it actually needed the cart. So it probably was 1.25 inches. It might have even been a 20-foot piece, but I don't think it was. Whatever it was, we did that. And so that was a learning experience there. And another thing here with floating, I was mentioning just recently on another video about one where we used a U piece to connect and move the compound from over here to do cutting in a different location. And I'd mentioned about making that piece out of 2-inch plate. Actually, and then that's part of what brought this floating to mind needing to be a video, I had not thought about it. I didn't make it out of 2-inch plate. I actually went the other way. I at first was thinking 2-inch plate. 2-inch plate was the thickest they had at the mill. And so I went the other way. I made it out of 3/4-inch plate because once I got to thinking about the 2-inch more, I wanted to make sure that I was not damaging the lathe by being able to force it. I wanted to limit how much force I could transfer through on the plate. So I went the other way when I thought about it more, went with 3/4-inch and then used a backup plate under here with a slide so that you can watch that other video if you want to, of course. And so use the slide to actually hold the force of the cutting. And so that was how I floated over here. Same thing as what we were doing there, different application of the same thing. I was letting this part here do the guiding in this direction while this still controlled it, and it was floating. Sometimes you float things. When I was doing a field machining, we did a field cutting where we cut 2,200 feet of plate with a machine that we built that clamped onto some rails and traveled along, had hydraulic drive, and we milled out we were milling out 7/8 inch wide by 1/2 inch deep. And I think we were around 6 inches a minute or so for our actual travel. It made fairly good time. And anyway, on that one, I used an air cylinder, actually an air can for a semi-truck that pushed the cutter down. And then it somewhat floated along. The rails guided it for positioning, but it used the air cylinder, had a little cam that was adjustable for depth, and then it would cut the length and the plates would come off. We were removing some welded plates. We had, actually I didn't use that one. I don't know why I was thinking. I think it's because it was gray. This is closer to my other stories about the, one of them that I was thinking of, yes, was back to the 2-inch plate and something which made me think again even more of making sure that I had some movement in there. We had a lathe like that, a little bit smaller at another shop, and the compound we had way extended out a long ways. We had some tooling on the end of a boring bar. We were doing just a little cut, and all of a sudden the compound went wham and broke in half. So as I had seen this in a shop, and the man that had that happen to him, he was worried about me getting mad at him, and I was the boss at that time, and I was like, no, because he was doing what I told him, and even if he had taken the cut a little quick, there's only so much you can do. And on top of that, when we looked at it, we didn't know about it before, and that machine was always a little bit rattly. It had a crack along the compound. It was halfway, had been broken probably the whole time that we used the machine. But that broke it away. But that's what made me aware of that right there. So now another machine we had, in fact, at that same shop, instead of a Cincinnati, it was Kearney and Trecker, but it was a number 2, just this size, and I had hooked onto it. It was something with a piece of structural iron. I don't remember what it was, but we had it hanging on the crane, and it's real common. Like I say, at first it was the precision ground floors. Well, it's the precision installed cranes a lot of the time. So we had the crane out here, and we were doing something. I was running the machine. Oh, I know what happened. I got called for a minute, and the machine table is running. And what happened was it got to a point that as the crane pulled this way, the cable length was wrong. And so it wasn't holding it up anymore. I forget how it swung, but somehow with the table moving, it swung to where the crane was no longer holding it up, and it just tipped the whole mill over. So it was bolted down very well, didn't hurt the mill, didn't hurt the cut. Really was concerning as it started to move, but it was just enough on the balance where it just kind of went plump and went back there, turned the crane on, tipped it back up, and the world was all fine again. But anyway, so the point with that is not the matter of that, there's the safety. When you're hooked onto something else, there's the safety aspect. But also, it just told me that if you got it, these tables do really good at holding things together, because it tipped the whole mill over and held it and still was in position where the cut was still where it needed to be. So if you've got it bolted down good, lots of clamps, bolted down good, it's amazing. You may not see the machine probably as rocking some, or the crane, or Now, I've also never done it with a machine that was fully bolted to the floor like you're supposed to. And I also know that there's almost never been a shop I've been in that had the machines bolted down. We bolted down shears, big plate shears, stuff like that. I've seen radial arms bolted down. Most machines I've been around, for all of the specifications, the manufacturer says they're not bolted. And I think that's better for most of us. I think it's overrated to be bolting it down, especially when you look at all the specs with a 6-foot thick, 22-foot wide piece of concrete to go under a number 2 milling machine. I mean, they don't ask that much, but still, it gets insane what these manufacturers want for a foundation. So now we get to another point of this. Let's say that we're doing something where we do have a problem with this. And I did one some years back with a set of forklift forks. They were 10-inch wide, I think. I had to take, I don't remember, ½ inch or something off of them, 8 foot long. Not huge. I've actually worked with some bigger ones here since. And in fact, we've taken bigger ones. We've got a saw set up so we can rip saw to thin down forklift forks. It's demoted since we got the new saw, but we've still kept it because it's kind of a handy thing to be able to do a long rip sawing operation. So anyway, what I did with those, and I did it on this mill right here, I clamped it on. I did not have the crane. I had my forklift, and the forklift had leaky mast, no brakes, wasn't going to hold it where I wanted. I knew this was not going to work. But this is a $4,000 job. And John don't have $4,000 at this point. This is really important. John has Cincinnati Mill, he has bills he's gotten, and he's on his own. He's the big shop boy. Anyway, so what I did, I had a surplus 16-inch air cylinder. I hooked the air cylinder up with the forklift, held it up with the forklift, and put air to it and adjusted the regulator pressure so it just took the weight off of it, cranked the table a little bit, back and forth, moved it around so I could see whether I was fighting it or not. And when I got it to where it would swing and move a little bit and be about right, I figured that's the right air pressure for it. And so I aired it up, we'd move a ways, then I'd block it, move the forklift over, go a little bit further, and work it back and forth and get the thing done. And it worked out pretty good. The one thing that was bad about it, though, was, again, years ago, it was before I had my big air compressor. I had just my little homeowner air compressor, so the air compressor for the 6 or 8 hours I was taking the cut that was going blah, 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 I felt sorry for it. And that thing did me good for 19 years, just barely enough air. We still kept it. It's for backup. It's out here in the ice, covered up. But anyway, so the fact that you can move stuff, which was the same thing I did again on that one with the portable cutting. I used the air cylinder to put it down, travel it. The one thing that's bad with that is now when you have that air cylinder that comes down to first start the cut, you have air on this side and you don't have anything on the other side. And there's a trick for how to do that, but I'll either keep it my own trick because very few people think about it, or I'll tell you in another video. But so anyway, you float things. Let them move a little bit so that they follow along with your machining.